We now step up from the baby problem to the teenager problem. So here, instead of only one variable q, we now have a set of variable qj. In the baby problem, we had only one integral. Now we will have to generalize that to n integrals, one for each of the variables. So there is one source for each variable qk, and that's why we sum over k here. For the interaction part, all the q's need to be the same variable. Otherwise, we won't be able to generalize to a local interaction when we will move to field theory. And for the first term, we now have the possibility to couple two different variables, so qk and qj, through this matrix A. We could not do that initially with the baby problem because we had only one variable. We already solved this integral in the case of lambda equal to 0, because that's just a Gaussian integral. Now that we have lambda, we do not know how to solve this integral a priori, so therefore we are going to Taylor expand in lambda. And we also need to rewrite the source term. As before, we see that we can replace each q for n by a derivative with respect to ij. The exponential of the derivative with respect to j do not depend on q, and therefore they can be moved outside of the integral. We now recognize a Gaussian integral, where the matrix D is just the inverse of the matrix A. So as in the baby problem, we managed to write our many integrals in terms of just an exponential of derivatives acting on a function of the sources. And we just now have to generalize that in the case of field theory.